Question number 3. In what condition that a charged particle experience magnetic force? Yeah, so let's say you have a particle that says a particle positive or proton. So when the proton enter to the magnetic field B or region magnetic field B, right? This is a B. So now the combination of the speed of the charge of V, right, and magnetic field B, yes, we have the force, and the force here is the force X on the positive charge. So you can use your left hand, right? So this is the finger is direction of the force, and the thumb, finger, your thumb is direction of the B, and the second finger is direction of the V. This is a speed of the charge. So this is 90 degree. This 90 degree. So now direction of the B into the page, because this is the symbol of B into the page, and direction of the a particle is to the right. So this is 90 degree here compared to the B. And if you use the left hand, so direction of the force is to the upward. And if you look at the diagram, this direction of the F to the upwards, right? So meaning the charged particle experience magnetic force when enter into the magnetic field B. And number 2, two charged particles moving in the same direction and projected perpendicular into the uniform magnetic field. So you know you have let's say the same diagram here. You have let's say the positive charge, and the second you have we have another charge here, negative charge. Okay, and the particle deflected opposite direction. Yeah, if you use a positive charge here, meaning the direction of the force, use a left hand, direction of the force is the upward. But if you use the negative, you must use a right hand. So if you use the right hand, still the thumb is direction of the force X on the charge, and first finger is direction of the B, and the second finger is direction of the V. So now for the negative charge, use the right hand, so the direction of the force is opposite direction, is downward, right? So meaning it's the deflected opposite direction, so because of the charge, magnitude of charge is dislike charge, positive and negative charge. Next question is number B. A circular loop L1 of radius 5 cm carry 15 ampere currents. So number 1, calculate the magnetic field at the center. So meaning you have let's say you have a loop, and the current flow in the loop 1, let's say this is loop 1, is current flow is 15 ampere, and the radius of the loop here is 5 cm. So now the question asks you to calculate the magnetic field at the center. So what is the B here? So to calculate the B, you can use the equation B for the loop at the center. B is equal to nu naught I divided by 2R. So this is I. So now the value of the nu naught is constant. As you know, this is 4 pi exponent minus 7. The I is 15 ampere, and 2 times R is radius, 5 cm convert to the meter is 5 exponent minus 2. So now the B at the center for the loop 1 is equal to 1.89 exponent minus 4 Tesla. And the next, number 2, another loop L2 of radius 1.5 cm. Right, we have L2 here, and 50 turn, carrying the 2 ampere. 15. The current here is, let's say this is given as 2 ampere, and this is loop 1. Number of turn is 50 turn, right? So have 50 turn. So now what is the resultant? So the question asks you to calculate the resultant magnetic field at the center if the current is the same direction. So we focus on the diagram here, right? This is the diagram here. The first, for the loop 1, from the answer number 1, B1 at the center is 1.89 exponent minus 4. So now we have another loop L2. So for the L2, the B produced by the L2, same equation, B mu naught I, this is I, L2, this is I2, and 2R, the radius here. So the radius here for the second loop is given by the equation. The radius here is 0.015 meter, right? The radius here. So now your naught is constant. Your naught is constant, 4 pi exponent minus 7. And the I2 is given by the equation. Current flow for the loop 2 is 15, right? 15 ampere, and the radius here is 0.015 meter. So now the B2 is equal to 4.19 exponent minus, this is minus 3, just calculator, this is minus 3 Tesla. Now you have the center, you have the center here, you have the 2B here. So first this is a B1 and plus B2, because the current flow is the same direction. Let's say this is direction, the same direction, meaning that at the center here, the direction of the B1 and B2 is the same, so you can plus. Here is total at the B at the center is a B1 plus B2, and the B1 here we have from the question number 1, 1.89 exponent minus 4 Tesla, and we have another B or B2 is a 4.19 exponent minus 3. So now the total B at the center is equal to just calculator, 4.38 exponent minus 3 Tesla, right? Continue number 3. If the L1 in figure 4 is fixed but L2 is free to turn about its central axis, what will be the torque on the loop L2 when its plane is parallel to the loop? Again, we refer to the diagram here. So now the L2 is free and the L1 is the fixed. So meaning the B, let's say the B produce a magnetic field produced by the L1, okay, B1, this is equal to 1.89 exponent minus 4 Tesla x to the loop 2, but the loop 2 is free. So meaning the process here produce torque on the loop 2, because of magnetic field produced by the loop 1. So the torque equation, torque is given by the equation number of step n time current flow. Now the current flow here is referred to the current flow in the L2 and area A, right, the plate loop 2, and times magnetic field P sine theta, right? So because the plane of the L2 is parallel to the loop 1, so meaning the angle theta here is equal to 0, or this is sine 0 is equal to 0. So now the top x loop 2, right, here is equal to 0. So next question number C, a 2 ampere current flow